सर।
जी जी।
सर मैंने आपसे एक
सॉरी, मुझे आपकी आवाज नहीं आ रही।
सर मैंने पूछना था सर, एक ये रूल होता है कि मतलब कि अगर ड्यूरिंग इंटीग्रेशन, अगर क्या कहते हैं आप, यानी कि जैसे साइन स्क्वायर एक्स है तो उसका डेरिवेटिव मल्टीप्लाई हो रहा है कोस एक्स, तो हम उसकी पावर जैसे कि इंक्रीज करके साइन क्यूब एक्स ओवर 3 + c ऐसे करके लिख सकते हैं ना सर ये?
नहीं नहीं, नहीं कर सकते। अच्छा, सात सात मल्टीप्लाई हो रहा है, अच्छा।
जी सर।
अगर सात मल्टीप्लाई हो रहा है, या फिर कर सकते हैं। दिस
सर
इज, बट दे डोंट एक्सपेक्ट यू टू नो दिस। मतलब ये एक रूल होता है वैसे, बट अगर ये आपको आएगा, दे विल आस्क यू टू डू इट यूजिंग सब्स्टिट्यूशन। इनफैक्ट ये वाली सब्स्टिट्यूशन एक आपको आनी चाहिए, क्योंकि ये यूज होती है साइन, इनफैक्ट ये होगी कॉस क्यूब को इंटीग्रेट करने के लिए। सो वन ऑफ साइन क्यूब एंड कॉस क्यूब, बिकॉज अगर यहाँ पे होता साइन क्यूब एक्स, तो उसको हम ब्रेक करते तो बनता साइन स्क्वायर एक्स इंटू वन माइन इंटू साइन एक्स, विच वुड हैव बिकम 1 - कॉस स्क्वायर एक्स। तो उसमें आपके पास कॉस स्क्वायर इंटू साइन आता। अच्छा, तो ये इंटीग्रेशन जो है, ये आपको करना पड़ेगा कॉस क्यूब की इंटीग्रेशन करते हुए, और इसके लिए सब्स्टिट्यूशन यूज होती है u इक्वल्स साइन एक्स। तो ये असल में सब्स्टिट्यूशन से होता है। मतलब सब्स्टिट्यूशन से भी हो सकता है। दिस इज अ रूल एज वेल, दैट इफ यू हैव समथिंग लाइक द साइन एक्स होल स्क्वायर्ड इनटू कॉस एक्स, अगर इसका डेरिवेटिव बाहर मल्टीप्लाई हो रहा है, तो इस पे आप पावर रूल एक तरह से अप्लाई करके डायरेक्टली इसको कर सकते हो, साइन एक्स होल क्यूब ओवर 3। ओके, बट दे डोंट एक्सपेक्ट यू टू नो दिस एक्सेप्ट दिस वन केस। अदरवाइज वो हमेशा इस तरह की सब्स्टिट्यूशन आपको देते हैं क्वेश्चन के अंदर।
ओके सर। सर बेसिकली ये मेरे स्कूल के सर ने बताया था, वो कहते थे कि ये एफएससी रूल होता है बेसिकली, कोई इसके अंदर इस्तेमाल होता है।
ये यूज हो सकता है, बिल्कुल यूज हो सकता है, आप कर सकते हो उसको यूज, लेकिन इसके बगैर भी आपके क्वेश्चंस हो जाते हैं, because they don't have this explicitly as part of the syllabus Cambridge में, वो explicitly part syllabus का part नहीं होता। ओके, अच्छा, लेकिन आप यूज कर सकते हो उसको बिल्कुल, if you understand you can use that. Okay, so let's start with this then. March 2021, paper 3, variant 2. We are going to be doing difficult questions from this paper today. Let's start with this March 21, paper 3, variant 2. Let me just quickly have a look at this as well, if anyone has responded there. Okay, let's start with this then. So, since a lot of people are focused on S1 now for the Monday exam, what I'll do is I will be choosing the difficult questions myself as well. I can see your suggestions in the chat group and the chat box as well. But I'll be choosing some questions myself that I think look relatively difficult. Okay, so let's start with this. March 2021, paper 3 variant 2. Let's begin with this. In the first question, you just have to solve this equation. It's a standard log question. Should be doable. Then you have to divide ax cubed plus this by, no. So you're given that this is a factor. And you're also given that when p of x is divided by x plus 2, the remainder is 2. Find the values of a and b. Just use remainder theorem and factor theorem here. Make 2 simultaneous equations and find the values of a and b. That's pretty straightforward as well. Question number 3. Okay, so this needs to be written as a quadratic equation. Again, you just apply compound angle identity here. Write cot as 1/tan, and then just simplify everything. You will get a quadratic equation from that. You solve it like a quadratic equation, then it's not that complicated. This is also doable. Okay, so let's start with this question. Okay, so this is the first question that you suggested. Okay, let's start with this one. Question number 4 from this paper. It says the variables x and y, they satisfy this differential equation. 1 minus cos x into dy over dx equals y into sine x. It's given that y equals 4 when x equals y. Solve the differential equation, obtaining an expression for y in terms of x. It's a 6-mark question, not that many marks for a differential equation problem. So hopefully it should be not that difficult. What we do is we separate the variables. First of all, y comes here, 1 minus cos x goes to the other side. And yeah, so this is actually a simple integration. But let's do this quickly. 1 over y into dy. On the other side, you would have sine x over 1 minus cos of x dx. All right, that's what the equation turns out to be. Now, how do you integrate the left-hand side? Now that you have separated the variables, you can just integrate both sides separately, integrate the left-hand side separately and the right-hand side separately. What's the integration of 1 over y? It's ln of y. What about this fraction? 1 minus cos x. We need to differentiate this. What's the derivative of 1? It's 0. Derivative of cos is minus sine. In fact, derivative of minus cos, what's that going to be? Derivative of minus cos, minus remains as it is. Derivative of cos is minus sine, and that gives you sine of x. So that means the derivative of the denominator is already there in the numerator, right? Sine x is the derivative of 1 minus cos x, so numerator is the derivative of the denominator. This is the standard ln rule that you can work. This is the standard ln form. The right side can be integrated like this. You would say this is ln of 1 minus cos x, and then you put plus c here. And that's your differential equation solved as far as the integration part is concerned. Now you just need to find the value of c from this. Let's see what that turns out to be. We are given that y equals 4 when x equals pi. Let's input those values. Y equals 4 and x equals pi. What do we get from this? ln of 4, that equals ln of 1 minus cos of pi plus c. Let's simplify this. ln 4 equals ln of 1 minus cos of pi. What is cos of pi? Cos of pi is -1. So this becomes 1 minus -1 plus c. And that's ln 4 equals ln of 2 plus c. And c equals ln 4 minus ln 2. You can leave it like this for now if you want. You can also simplify this because you can use the division log here. This is subtraction outside log. This can be written as division inside, so it becomes ln of 4 over 2, which means c equals ln of 2. That is what we were looking for. We found the value of c. Now this becomes ln y equals ln of 1 minus cos of x plus ln of 2. And now we need to make y the subject because the question asked us to obtain an expression for y in terms of x. Now, one possibility could be that you could say that, okay, the base of ln is e, take that to the other side and make it and write it like this, e raised to power ln of 1 minus cos x plus ln 2. That is y in terms of x. However, this is not simplified enough. You want to simplify this expression further. This is not going to get you full marks if you write it like this. So generally, you do not want to have ln as a power of e in problems like these. In the final result, you should avoid having ln in the power of e. Okay. Now, what do we do instead then? Well, we have ln in every single term. So what we can do is we can try to get rid of ln somehow. How can we do that? On the right side, we have plus outside the log. We can write this as ln of 2 into 1 minus cos x using the multiplication law. Addition outside becomes multiplication inside. So you have 2 into 1 minus cos x inside. And now you have a single log on both sides. So you can say y equals 2 into 1 minus cos of x. And this is a much simpler form, and that's what they would expect from you. You can write it like this, or you can say this is y equals 2 minus 2 cos x. Either of them are going to be is going to be acceptable. Okay, that's for question number 4, part A. Now it says sketch the graph of y against x for x between 0 and 2 pi. Now you've already found y in terms of x, and what's that? Y in terms of x is y equals 2 minus 2 cos x. Now they expect you to draw the graph of this function, sketch the graph of this function for only 1 mark. Never do this in the middle of the exam. Too much effort for 1 mark, skip this, do the rest of the paper, and then if you have time at the end, then come back to this. 1 mark, sketching a graph, that's too much effort for 1 mark. I would definitely recommend to skip it when you are going through the questions the first time. Don't spend time on this in the middle of the exam, okay? That can cost you some easy marks at a later, towards the end of the exam, towards the end of this paper, okay? So don't do that. But since we are not in exam condition right now, what I'm going to do is I'm just going to sketch this right now. The easiest way and the quickest way, not the quickest way, but the easiest way is to sketch it using the table function on your calculator. Now this is going from 0 to 2 pi, right? So we need positive values of x only. 0 to 2 pi. Okay, now what I'm going to do is I'm just going to use this table function on my calculator to basically get some values of x and y. All right, let's go to the table. F of x equals, now your calculator needs to be in radian mode, right? Because we're doing 0 to 2 pi, that's in radians. F of x equals 2 minus 2 cos of x. All right. Skip g of x because we only have one function here. Start at 0, end at 2 pi. And then step, let's take a small, relatively small step so we have enough values. This is pi, this is going to be pi over 2, and then this is going to be 3 pi over 2. Let's take a step of pi over 2. So we have values at each of these points, and that's it. That's your table. Now you can see the values that you've got. 0, so it starts from 0. The graph has to start from 0, and then it's going to 2, 4, 2, 0 again. Okay, so minimum value on your in your table is 0. Maximum value is 4. So let's mark 4 here. This is y-axis. We've got 2 here, and 0 here, and 3 here. Let's mark those points. At 0, it's 0. At pi over 2, so the next value has to be pi over 2, right? Because the interval was pi over 2. So that's 2. Let's mark this point here. And then you have 4 after that. You have 4 here. And then you've got 2 here. And then finally, you've got 0 again. Now, these are the points that you get. Now, once you've got these points, you also need to have some understanding of what the cos graph looks like, right? The standard cos graph looks like this. Okay, this is one possibility. If it is reflected, it would look like this. It has to be one of these two shapes. They can't be something else. Okay, so you need to have some idea of how the graph looks like, and then using that, you can basically sketch this graph. So it would actually look like this. It would go like this, and then the curve's direction would change. Then it will be like this, and then like this. Now, if you're not even sure about the shape of the graph like this, what you would have to do would be you would have to take even more points. So instead of taking an interval of pi over 2, you could take an interval of a step of pi over 4. That will give you more points. And then when you mark those points afterwards, you will be able to understand the shape of this graph as well. Okay, so you'll get these points if you take an interval of pi over 8. Okay, then you can draw this graph as well. But I would suggest at least have some idea of how the graph is supposed to look like. And then you can just make a table and sketch this graph like this. Okay, so that's what you had to do in this part. Let's move on to the next one. Question number 5, it's a standard question, sine of x plus alpha. Yeah, so you just have to use the formulas. These are standard forms, sine of x plus alpha. This is a, this is b. Just use the formulas r equals square root of a square plus b square, and tan alpha equals b over a. You can find these values. That's pretty straightforward. And then second part, using that, you just have to replace x in this form with 2 theta. Okay, I'm sorry. Just have to replace x with 2 theta and then solve that equation, right? It's not that difficult. You can do that. And you have partial fractions. We did something like this in our yesterday's class on March 2024 paper as well. Yeah, now this looks kind of similar to that. Let's do this. Okay, let's do this part as well, this question as well, because this was tricky in that paper as well. Let's do it here again. So we have partial fractions, but what they've done is they've written this value in terms of a here. How do you find partial fractions for this fraction? These are non-repeated linear factors, and it's a proper fraction. Why? Because the degree of the numerator is 0. The degree of the denominator is 2. Okay, it's a proper fraction. So what is going to be the standard form for this? 5a over 2x minus a multiplied by 3a minus x. This is supposed to equal a over 2x minus a plus b over 3a minus x. Okay, this is what it's going to look like. Now, we multiply this denominator on the right side. What does that give us? That gives us 5a identical to a into 3a minus x plus b into 2x minus a. And now we input some values of x. So how do you make this 0? For this bracket to be 0, we would need x equal to 3a. So we start from that value. We say let's input x equal to 3a so that this term gets eliminated, and we can find the value of b from that. Let's see what we get from this. We get 5a on the left side. On the right side, this whole term becomes 0 when we put x equals 3a plus b into 2 into 3a minus a. Now that gives us 5a equals b into 6a minus a, that is 5a. The value of b turns out to be 1. Now we have to input another value for x. How does this bracket become 0?
Sir?
X equals a over 2, yes?
Sir, won't it be 1a?
It would be 1a? No, why? A and a also get cancelled. When we divide it on the other side, it's 5a over 5a. That's just 1.
Okay,
right?
sir.
Let's input x equals a over 2. Now, when that happens, we get 5a equal to a into 3a minus a over 2 plus 0, because now this term becomes 0. Right? Now let's simplify this. 5a equals a into 6a minus a, that's 5a divided by 2. And that will give us a equal to 2. Okay, 5 and 5 would get cancelled, and we have 2 on the other side, a equals 2. So we've got our partial fractions. Now the partial fractions will look like this. We've got the values of a and b. Let's put them here. These are the partial fractions then. 2 over 2x minus a plus b, which was 1. So that's just 1 over 3a minus x. These are the partial fractions that we were looking for. F of x equals this. Okay, so we found the partial fractions. Now let's look at the next part of this. Now it says, hence show that this integral evaluates to ln of 6. So now once we have found the partial fractions for that, we can integrate each of these fractions separately. 2 over 2x minus a. Let's integrate that separately with respect to x, plus integral of 1 over 3a minus x, 1 over 3a minus x with respect to x. Limits for both of them are supposed to be from a to 2a. Okay. Now, what's the integration of this fraction? You can use the ln rule on this because the derivative of the denominator is there in the numerator. What's the derivative of 2x minus a? It's 2. We've got 2 in the numerator. So this integrates to ln of 2x minus a plus. How do you integrate this now? Again, what's the derivative of the denominator? Remember, a is a constant, so derivative of a constant is just 0. What's the derivative of minus x? Derivative of minus x is minus 1, so we want minus 1 in the numerator. Now, in order to get minus 1 in the numerator, what we can do is we can multiply by minus 1 inside, and then to balance that, we can make this sign negative outside, and we get something like this. Now the form inside is the ln form. So this becomes minus ln of 3a minus x. And the limits are from a to 2a. Now we just have to input those limits. Let's input 2a once. ln of 2 into 2 times a minus a. Subtract from this ln of 3a minus a. Sorry, minus 2a. This is what we get when we input 2a. Subtract from this the case when you input x equal to a. And that gives us ln of 2a minus a minus ln of 3a minus a. Let's simplify everything. This gives us ln of 3a, right? This is 4a minus a, that's 3a, minus ln of a minus ln of a plus ln of 2a. And this simplifies to ln of 3a minus 2 ln a plus ln of 2a. And now what we need to do is we need to get rid of these a somehow, because our final answer is supposed to be just ln of 6. Now, how do you get rid of these a's? What we can do is we can split these logs like this. We can say ln of 3a, this can be written as ln of 3 plus ln of a, right? Using multiplication of, this is multiplication inside, it becomes addition outside. So we could write ln of 3a as ln of 3 plus ln of a. And then similarly, minus 2 ln a, that remains as it is. What about ln of 2a? We can break this into two parts as well. We can say this is ln of 2 plus ln of a using multiplication law again. And now you see you've got ln a minus 2 ln a plus ln a. These terms get cancelled. And we are left with ln of 3 plus ln of 2. We want to prove that this is ln of 6. We can use multiplication law here. So this becomes ln of 3 multiplied by 2, which is ln of 6. And that is what we wanted to prove. That's the final result that we get from this. Make sense? That was part B of this. This was not as tricky as the one in March 2024, because in that one, we had three factors in the denominator, so it became a bit lengthier. But the method was exactly the same for both parts, okay? All right, now let's move on to the next one. Okay, so we have to show that these lines are skew. That's a standard method, not much complication there. And again, the acute angle between the directions of the two lines, fairly easy vectors question. Then you have these complex numbers, find u over v, and then express this in this form. State fully the geometrical relationship and prove that angle AOB is 3 pi over 4. Okay, let's have a look at this as well. Question number 8. So the first couple of parts, they look fairly straightforward, but let's see what happens after that. In the first part, it says find u over v in the form x plus y iota, where x and y are real. So how do we divide two complex numbers? U over v, what is that going to be? Minus 4 plus 2 iota divided by 3 plus iota. Let's do this quickly. It's a standard process that you need to know about. You multiply and divide by the conjugate of the denominator. This becomes minus 12 plus 4 iota plus 6 iota minus 2 iota squared divided by, you've got a plus b into a minus b in the denominator. So you've got a squared minus b squared, that's 3 squared minus iota squared. Let's simplify this further. It becomes minus 12 plus 10 iota minus 2 into minus 1. In the denominator, you have 9 minus minus 1. And in the numerator, you get minus 12 plus 2, which is minus 10, plus 10 iota. In the denominator, you have 9 plus 1, which is 10. And now you take 10 common from the numerator. That gets cancelled, and you're left with minus 1 plus iota. That is u over v. Okay, that's the first part, fairly straightforward. Now it says, hence express u over v in this form, where r and theta are exact. Now, how do you do that? This number, we just have to find the modulus of this and the argument of this, and then write it in this form. What's the modulus of that number? U over v modulus, or let me actually just write it like this first. U over v is this number, minus 1 plus iota. What's the modulus going to be? It's square root of 1 squared plus 1 squared. And that is square root of 2. And what about the argument? You first find the basic angle. Tan alpha equals 1 over 1, alpha equals pi over 4, right? Tan inverse of 1 is pi over 4. That's the basic angle. And now you need to think about which quadrant this is in. Which quadrant is this? Real part is negative, imaginary part is positive. So you have to think about which quadrant we're talking about. It's going to be in the second quadrant. Real part negative, that means on the left side. Imaginary part positive, that means upwards. It may be somewhere around here. Okay, this angle is supposed to be pi over 4. So what's the argument then? Argument is measured from the positive real axis, from here. So what's this angle going to be? That's the argument. You would say argument, or theta, that's another notation that we use for argument. That is going to be pi minus pi over 4, and that is 3 pi over 4. That is the argument of this complex number. Now, once we've got the modulus and the argument, we can say u over v can now be written as r e raised to power iota theta. R is square root of 2, e raised to power iota theta. That means 3 pi over 4 iota. And that's what the complex number looks like in r e raised to power iota theta form. All right, so we got this as well. Now let's move on to the next one. In the next part, it says, in an Argand diagram with origin O, the points A, B, and C represent the complex numbers u, v, and 2u plus v respectively. State fully the geometrical relationship between OA and PC. Now, this will become simpler if you just draw, if you just plot these points, right? It will be easier to understand that way. So what is the Argand diagram going to look like here? Let me draw a rough diagram here. And let's mark those points to understand the situation better. So what does it look like? You've got origin in the middle. This is the real part. This is the imaginary part. Now, A, B, and C represent the complex numbers u, v, and 2u plus v. Now, what is u? U is minus 4 plus 2 iota. Where is that going to be? On the left side. So let's say this is 2, this is 4 on the vertical axis, this would be 1, and then we can say this is minus 2, this is minus 4. Make sure the scale on both axes is the same. That is going to be important. Otherwise, you might not be able to understand the relationship easily. Okay, so minus 4 plus 2 iota. This is going to be the point u. Okay, let's mark that point, minus 4 plus 2 iota. And then v, what's point v? V point is 3 plus iota. Okay, where is 3 plus iota? 3 and iota, that is going to be here. This is the second point. This is v. Now, u, they're representing u by a here. This is a. And they're representing v by b here. So this is b. And o is the origin. And then you have another complex number, which is 2u plus v. Now, how do we evaluate this other complex number, 2u plus w? That's not that complicated. You can just use those individual complex numbers that you were given, minus 4 plus 2 iota. Let's put that here. 2 into minus 4 plus 2 iota plus v. V was 3 plus iota. What do we get from this? This is minus 8 plus 3, which is going to be minus 5. And then 4 plus 1 plus 5 iota minus 5 plus 5 iota. This is the complex number 2u plus v. Where is this going to be? Minus 5 and plus 5.
Sir, sir, I cannot hear you.
And got it. You can hear me now, right? And my screen is shared. Is that correct? Okay, good. All right. So this typical relationship between OA and BC. Okay. So what's OA and what's BC? OA is
Sir, I cannot hear your voice.
okay. I'm sorry about that. I'm having some difficulty with my internet, I guess. But I think it's all right now.
Yes, sir.
Okay, so now you can hear me. All right, good. Okay, so yeah. So where were we? We were saying we have these 2 points, right? We have OA and BC. We've got two sets of points. Now, what's the relation between OA and BC? Now, how do we think about this? And you see, you've got 2 marks, and they've asked you to state fully the geometrical relationship between OA and BC. That means you have to write everything that you can figure out, right? So basically, generally, if it's 2 marks, you'll have to write 2 statements, 2 relationships between the 2 lines that we've got. Okay, it's just like when In paper one, they used to say factorized fully, factorized completely. That means if you get a quadratic factor, you have to factorize further as well. Now, in this case as well, they're saying state fully, and you have 2 marks. You'll get 2 marks for 2 statements. You need 2 relationships between these 2 lines, OA and BC. Now, how are they related? Now, number one, they look parallel, right? They look parallel, but we need to confirm that. How can we confirm that? This is this point. Let's actually mark this point. This is going to be 3 and 1, and point C is -5, 5. And what about point A? Point A is -4 and 2. Okay, now this point is 4 units to the left and 2 units up from the origin, right? So if you think of it like this is 4 units left and 2 units up. And if you think about the point, if you think from B to C, how do you go from B to C? This is 1 vertically, horizontally it's 3. So you're going from 3 to -5, that's 8 units. And then 1 to 5, that is 4 units. Okay, good. So that actually tells you something. You can see this distance is 8 units. The green distance is 8 units horizontal. This distance is 4 units. And vertically, this is 4 and this is 2. So if you find the gradients, you can try that. They have the same gradient, right? Because the rate of change, you can see they're parallel. Rate of change is the same for both of them. So these 2 are supposed to be parallel. That is one thing. OA and BC, they are parallel to each other. You can find the gradients and they turn out to be the same. Both the gradients are -0.5. Okay, the gradients are the same. Okay. All right, O and BC are parallel. Now, what about another relation? So can you think of something else now? We saw that horizontally, this was 8 units and this was 4 units. And vertically, this was 4 units and this was 2 units. So basically what that tells you is the sides of this yellow triangle are half the sides of the green triangle. So what about the third side as well? It should be the same relationship there as well. That means BC should be 2 times OA, or OA should be half of BC, right? You can think of it both ways. You can say, for example, you can say BC equals 2 times OA here, right? It's twice the length of OA. These are 2 statements that you would have to make. You get 1 mark for one statement, 2 marks for writing both statements. Now, it's very difficult to figure out just by looking at it right like this. You have to draw an Argand diagram and then try to figure out the relation using that Argand diagram. Okay. All right, that's part C. Let's look at the next part now. It says prove that angle AOB is 3 pi over 4. Angle AOB is 3 pi over 4. Okay, so this is the angle that we want to find now. Let me mark it with another color. AOB. We want to find this angle somehow. Now, how can you find this angle? One idea is that you could use cosine rule. You can find all sides, then use cosine rule. That is one possibility. Or you could find the 2 angles separately. What I'm going to do is I'm just going to copy this diagram so we don't make too much clutter there. So you can use these notes later on to revise as well. I just copy this diagram. Okay, so this is what that diagram looks like. We are looking for the angle OA, angle AOB. Now C is no longer relevant. I'm just going to get rid of that. Okay, so this is the angle that we're looking for, AOB. Angle AOB. Now, how can we find this angle? What we can do is we can either make a triangle like this full triangle, like this, find three sides, and then use cosine rule. That will take quite long, right? Because you'll have to find three sides, and then you would have to use cosine rule after that. An easier way of thinking about this is you could break it down into two parts. You could say this is one right angle triangle. We can find this angle. Let's call this angle alpha. And then this is another right angle triangle. Or is that right angle? Yeah, this is another right angle triangle, like this. Use these two right angle triangles. Let's call this angle beta. You can use these right angle triangles to find alpha and beta, and then you can just add those two numbers together, right? You'll get the complete angle AOB. So you can find alpha and beta separately.
Sir,
Now, how do you do? Yes.
sir, if we draw a vertical line at -4 and 2 and find the inner angle of the triangle and
Okay.
subtract
Okay.
it
Okay. Okay.
from.
Okay. 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 Just give me a minute. -4 and 2. Okay. Vertical line at -4 and
And we find the angle that is basically at O, in the inner angle of the
this
triangle.
angle.
Yes, yes, sir. Can we find it?
Okay.
And
Yes.
then we can
That's
subtract
also
it
all right.
from 90.
Yeah. It's the same thing. You'll get this angle, but you still have to find this angle separately. So it'll be still the same amount of working, or maybe slightly more. Okay.
Okay,
All
sir.
right. So how do you find alpha and beta? Let's find the value of alpha first of all. Now, what do we know about alpha? We know that this side is 3 and this side is 1. We can use tan. Tan of alpha would equal 3/1, right? Tan of alpha equals this. But the problem is we want an exact answer at the end, 3 pi/4. Okay, so the answer has to be exact. Tan inverse of 3, I don't think that's an exact number. So we cannot use this. This is not going to give you an exact result. Tan inverse of 3, on the other side, you'll have tan inverse of, okay, let me just try to figure this out this way. If it's tan alpha equals 3, and then you have the other angle, tan of beta, this length would be 4 units, and this length is 2 units. That gives you tan beta equals 4/2. That means tan of beta equals 2. So you have tan alpha equals 3 and tan beta equals 2. We need to find alpha plus beta somehow. Alpha plus beta. Now, how can we find alpha plus beta? Okay, so one idea could be that we do that tan of alpha plus b. That will give us, and then we do tan inverse at the end. That should give us an exact answer. Yeah. So one idea we could do is we could say, since we want alpha plus beta, we want that complete angle, right? So angle AOB is basically alpha plus beta. This is the complete angle that we've got, right? We want this complete angle. Now, we could say, what is tan of alpha plus beta going to be? Tan of alpha plus beta is given by tan of alpha plus tan of beta divided by 1 minus tan alpha into tan beta, right? And now we know these values. We know tan alpha, we know tan beta. So this becomes 3 plus 2 In the denominator, we have 1 minus 3 into 2. Let's see if this gives us an exact number. 1 minus 3 into 2, right, in the denominator. Let me use brackets correctly here. And then we have 5 over minus 5. And that becomes minus 1. So we have tan of alpha plus beta equal to -1. Okay, tan alpha plus beta is -1. Now, since tan is negative, that means it's either the second quadrant or the fourth quadrant. Now you can see alpha plus beta, this is supposed to be an obtuse angle. So we want an angle in the second quadrant, right? The base, if you find the basic angle for this, tan inverse of 1 is 5/4, but since this is negative, and we won't know that the angle is supposed to be 4, what's the angle that we get here? That is pi minus 5/4. So alpha plus beta therefore pi minus pi/4, and that is 3. Okay, I'm really sorry. I'm having some internet issues today for some reason. Okay, I think you can hear me again now. Hopefully. Okay, so this is what we get, right? Alpha plus beta. I hope you're able to hear until this one. I'll just repeat this last step. So we know that the basic angle is 5/4. So it becomes alpha plus beta equal to this angle. What's this angle? This is pi minus pi/4. And that gives us 3 pi/4. That's the result that we get at the end. Okay? Make sense to everyone? No problem?
Yes, sir.
Okay, now that was quite tricky. The reason for it being tricky was that this angle was supposed to be exact. All right? This angle was supposed to be exact. And if we do it directly, tan inverse of 3, tan inverse of 2, that does not give us something exact. That will be a problem. Okay? All right, so that's it. That's part D of this. Let's move on to the next one. Let me see which other question you asked about. Okay, let's have a look at this as well now. Part A is straightforward. Part B is also straightforward. We have dash x that equals this. Okay, what?
Sir, I cannot hear you.
Okay, I'm sorry. I'm getting disconnected again and again. I'm back again. Hopefully, it does not happen again. Okay, so yeah, what was the equation that we were given? It said x equals f of x. That means x equals e raised to the power 2x plus 1 divided by e raised to the power 2x minus 1. Right? That's the equation. How do you prove that a root lies between 1 and 1.5? We take everything to one side. It becomes x minus e raised to the power 2x plus 1 divided by e raised to the power 2x minus 1 equal to 0. And now we say this is f of x. All you have to do now is input 1 in place of x, input 1.5 in place of x. The sign will be changing. You will write that the sign is different. That's why root lies between these two values, right? So that's fairly straightforward. You should be able to do that. And then it's iterative formula based on that. What's the iterative formula going to be? The iterative formula is going to be xn plus 1 equals e raised to the power 2xn plus 1 divided by e raised to the power 2xn minus 1. Okay, and then you start with x1, which is midpoint of 1 and 1.5, and that's going to be 1.25. And then you can write down the rest of the results, right? So that's really straightforward, not that difficult. It should be doable. Okay. All right, now let's move on to the next one. Part C, it says find f dash of x, hence find the exact value of x for which f dash of x equals -8. You just have to find the derivative of this and then put that equal to -8. Not that complicated, I think. Let's just have a look at the next couple of questions in case we would want to do one of them as well. Okay, so we'll do question number 10 as well. Do you want me to do question number this part C? Okay, let's do this quickly as well. Part C of this. F dash of x. F of x equals e raised to the power 2x plus 1 divided by e raised to the power 2x minus 1. This is what we're given. Let's find f dash of x. It's a fraction, so what we can do is we can use the quotient rule of differentiation. Let's do that. Let's use the quotient rule of differentiation. This is going to be u, this is going to be v. Quotient rule says it's vu dash minus uv dash divided by v squared. Okay, so denominator as it is, first of all, e raised to the power 2x minus 1 multiplied by derivative of this thing, derivative of the numerator, that is 2e raised to the power 2x minus numerator as it is, e raised to the power 2x plus 1 into derivative of the denominator, which is 2e raised to the power 2x whole divided by e raised to the power 2x minus 1 whole squared. That's what we get. Now, this is the derivative. This is what the derivative is going to be. We can simplify this. It becomes 2e raised to the power 2x into e raised to the power 2x. Powers get added, right? So it becomes 2e raised to the power 4x minus 2e raised to the power 2x minus e raised to the power 2x into this. That's going to be 2e raised to the power 4x minus 2e raised to the power 2x. In the denominator, we have e raised to the power 2x minus 1 whole squared. Now in the numerator, these terms get cancelled, right? Because they're both the same. One is positive and the other is negative. These terms, in fact. And this was supposed to be, sorry, power 2x. And what do we get from this? Minus 4e raised to the power 2x divided by e raised to the power 2x minus 1 whole squared. This is the result that we're getting for the derivative. That is what we were looking for, first of all. Once we have found the derivative, what we do now is we put this derivative equal to -8, right? Put the derivative equal to -8 and see what that gives you. -8 equals minus 4e raised to the power 2x divided by e raised to the power 2x minus 1 whole squared. Now we just need to solve this equation and see what this gives us. Multiply this on the other side, and you would have -8 into square of this thing. Could we simplify this a bit? Should we expand it or should we keep it like this? Let me think about it. If we keep it like this, okay, let's for now keep it like this in case we can get away with not having to solve a quadratic equation. This is minus 4 e raised to the power 2x. And now minus 8 over minus 4, we are going to have 2 into e raised to the power 2x minus 1 whole squared equals e raised to the power 2x. Now, if we take square root on both sides, that could work, right? If we take square root on both sides, square root of this, we would not have 2 plus minus 4. Okay, with square root, we might have a problem with plus minus. Let's expand it. That would be safer, I think. Let's expand it. This is a minus b whole squared. What does that become? A squared minus 2ab plus b squared. E raised to the power 4x minus 2 e raised to the power 2x plus 1 equals e raised to the power 2x. Okay, now simplify this. 2 e raised to the power 4x minus 4 e raised to the power 2x plus 2 minus e raised to the power 2x equals 0. And the equation turns out to be 2 e raised to the power 4x, 2 e raised to the power 4x minus 5 e raised to the power 2x plus 2 equals 0. Now, this can be treated as a quadratic equation because we have powers in the ratio e power, powers in the ratio 2:1. We can use quadratic formula here. We can say, let's use a substitution, replace the smaller power with u. It becomes u equals e raised to power 2x. If u is equal to e raised to power 2x, u squared is going to be e raised to power 4x. So we have this quadratic equation, 2u squared minus 5u plus 2 equals 0. Solve this quadratic equation. You can either factorize if that's possible. In this case, we could factorize. It becomes 2u squared minus 4u minus u plus 2 equals 0. Take 2u common, that leaves you with u minus 1, u minus 2 inside, minus 1 into u minus 2. You get two factors, 2u minus 1 and u minus 2. U equals 1 over 2 and u equals 2. These are the two possible results that I'm getting from this. Now put that substitution back. If you put that substitution back, we get e raised to the power 2x equal to 1 over 2 or e raised to the power 2x equal to 2. Now let's take ln on both sides for both of these equations. The first one becomes ln e raised to the power 2x equals ln of 1 over 2. Do you want an exact answer? Yes, exact value. And the second one becomes ln of e raised to the power 2x equals ln of 2. Now the first equation becomes 2x equals ln of 1 over 2. And x equals 1 over 2 into ln of 1 over 2. Now from the second equation, we get two x equals ln 2 and x equals half ln 2. These are two possible answers that we're getting, half ln 2 or half ln of 1 over 2. Now, the problem is in the question they said, find the exact value of x. That means you need to have only one answer, but we are getting two answers, right? So we have to ignore one of them. Now, let's see if we have any information given in the question that can make us eliminate one answer. Okay, so the question says x is supposed to be greater than 0. Now, are these both greater than 0? Well, ln of 1 over 2, try evaluating this on your calculator. Log of numbers which are less than 1, that turns out to be negative. So this number is basically negative. This is negative. So this is not possible. So the only possible answer is this. Why? Because in the question they said, x is supposed to be greater than 0. So you have to write down only one answer here, and that is 1 over 2 times ln 2. That's your final result. Okay, let's move on to the last one, question number 10, part A. Let's have a look at this. The diagram shows the curve y equals sine of 2x into cos square x for x between 0 and pi over 2 and its maximum point M. In the first part, it says, using the substitution u equals sine x, find the exact area of the region bounded by the curve and the x-axis. So we want to find this region. So we just have to use the formula area between a graph and x-axis that looks like this. Integration of y with respect to x, limits are from 0 to pi over 2. Now, how do you integrate this? For integrating this, they have asked us to use the substitution. Integration of sine 2x into cos square x with respect to x. In order to integrate this, they have told us to use the substitution u equals sine of x. Now, how do we use substitution in integration? What we have to do is we have to differentiate it first of all. Let's find the derivative. Du over dx. What's that? That is cos of x. And now, since we want to eliminate dx from here, we make dx the subject. Dx equals du over cos x. This is what we want to input here. Okay. And then you also need to change the limits because these limits are values of x. We have to change the limits. We say whatever is the upper limit, we write that here. Whatever is the lower limit, we write that here. What's the upper limit? Upper limit is pi over 2. Lower limit is 0. What does u become? U equals sine over pi over 2. Sine of pi over 2. Sine pi over 2 is 1. Right? Sine pi over 2, yeah, that's 1. And then u equals sine of 0. U equals sine of 0. Let's see what that turns out to be. That is 0. So the upper limit is now going to be 1 and the lower limit is now going to be 0. Okay. Now let's use that substitution. U equals sine x. Now the problem is we have a double angle here as well. So we should first simplify that before we actually use the substitution. Let's simplify that. Sine 2x, that can be written as 2 sine x into cos x. Right? And then you have cos square x on the side as it is. Limits are from 0 to pi over 2. Now let's use that substitution. In place of sine, write u. So it becomes 2 times u into cos of x into cos square x. That becomes cos cube x. Now replace dx with du over cos x. That becomes du over cos x here. Now 1 power of cos gets cancelled here. And what are we left with? We are left with integral of 2u into cos square x. What is cos square? Since we have this substitution, u equals sine x, we can convert cos to sine now. Cos square can be written as 1 minus sine square. What does that become? This becomes 1 minus sine square x. Okay, into du. And now we can use the substitution again. We can say 2u into 1 minus sine square. What was sine square? Sine square was supposed to be u. Sine was supposed to be u, so it becomes 1 minus u squared. And now we just need to integrate this. Now, you don't have to use integration by parts here. You can just multiply this, expand this bracket, and then integrate these two terms separately. 2u into 1, what's that? That's just 2u minus 2u cubed. Integrate these two terms separately and put the limits from 0 to 1. What's the integration of 2u? That's 2u squared over 2. What's the integration of 2u cubed? That's 2u raised to power 4 over 4. Input the limits from 0 to 1. Let's simplify this first. 2 and 2 get cancelled. 2 and 4 get cancelled. We have 2 here. Input 1 as the limit. That gives you 1 squared minus 1 raised to power 4 over 2. Subtract from this the case when you input 0. That's a 0 minus 0. Right? And you get 1 over 2 as the final result. That's the area that we were looking for. Okay, that's the first part. Fairly straightforward. You just have to use that substitution and use the standard substitution method for integration. Now part B, it says find the exact x coordinate of M. Now what's M? M is the turning point of this function. How do you find turning points? You differentiate and put that equal to 0. Put the derivative equal to 0. Y equals sine 2x into cos square x. Sine 2x into cos square x. That's what the function is. How do you differentiate it? It's a product, so you have to use the product rule for this. You can either apply the double angle identity for sine right now, or first find the derivative and then use that. So it's your choice. Let me actually keep it like this for now and see what that gives me. dy over dx. So what we can do is, first of all, we can write y like this. We can say this is sine of 2x multiplied by cos of x whole squared, right? So the second function is a power function. And now when we differentiate, we can say this is u and this is v. This is u and this is v. uv dash plus vu dash. U as it is, that means sine of 2x as it is, into v dash. What's the derivative of this? You have to use power rule in this. So it becomes 2 into cos of x power 1. What's the derivative of cos then? Minus sine. Plus vu dash, v as it is, that means cos square x as it is, into derivative of sine of 2x. What's the derivative of sine of 2x? Derivative of sine is cos, so it becomes cos 2x multiplied by 2. Now, since you're looking for the turning point, you put this derivative equal to 0, and that gives us minus 2 sine of 2x into cos of x into sine of x. Okay, then from the second term we get 2 cos 2x into cos square x. Now let's apply the double angle identity for sine and cos to simplify this. Sine 2x can be written as 2 sine x into cos x. And then you have cos x into sine x as it is, plus 2 into cos of 2x. Now we are not sure which of the three forms we should be using. We have three different forms for cos 2x: cos square x minus sine square x, 2 cos square x minus 1, 1 minus 2 sine square x. Now, since it's not clear here, you can use any of them. Let's use maybe, so since in fact this is cos square, to have everything in terms of cos, let's use 2 cos square x minus 1 here. And then you have cos square x multiplying on the side as it is. Okay, now let's simplify everything. This becomes minus 2 into 2, that is minus 4. Sine and sine, that becomes sine square x. Cos and cos, that becomes cos square x. Plus 2 cos square x into 2 cos square x, that is going to give us 4 cos square x. In fact, 4 cos raised to power 4x. Minus 2 into cos square x into 1, that is 2 cos square x. This is what we get eventually. All right. Now we need to somehow solve this equation. What do we do for that? We can take cos square common first of all, right? Cos square is appearing in every single term, and that will leave us with minus 4 sine square x plus 4 cos square x minus 2 equals 0. That means either cos square x equals 0 or minus 4 sine square x plus 4 cos square x minus 2 equals 0. Now, this is one equation that we're getting, cos of x equals 0. Okay, we need to solve this equation. Then what about this other equation? For the other equation now, we can see what we can do. We can convert it to either only in terms of sine square or only in terms of cos square. But before that, just before I go further, I just want to check my working again, just in case there's any careless error, because we don't want to find that out later on that we've done any mistakes. Let me just check this again very quickly. Sine 2x into 2 cos x into minus sine x, that's all right. And then derivative of sine 2x, that's cos 2x into 2. That makes sense. And we have minus 2 sine of 2x into cos x sine x plus 2 into cos 2x into cos square x. That's also all right. Then we have minus 2 into 2 sine x cos x. And then here we've got 2 cos square x minus 1. This is all right. Minus 4 sine square x into cos square x plus 4 cos raised to power 4x minus 2 cos square x. Okay. So it looks all fine. And then we have taken cos square common. That leaves us with minus 4 sine square x plus 4 cos square x minus 2. Okay, so it looks all right. Now, let's solve this equation. What we can do is we can convert it to one equation, one trigonometric function. Let's convert it to cos, for instance, plus 4 cos square x minus 2 equals 0. Let's simplify this. We get minus 4 plus 4 cos square x plus 4 cos square x minus 2 equals 0. And this simplifies to 8 cos square x minus 6 equals 0. And cos square x equals 6 over 8, which is 3 over 4. So this is what we're getting. Now we take square root on both sides. It becomes cos x equals plus minus under root 3 over 2. These are two equations that we're getting eventually. Okay, now we need to find the values of x. Let's look at this point m. This is supposed to be a positive value, number one, and they have said that x is between 0 and pi over 2. So this value has to be between 0 and pi over 2. That means it has to be an acute angle in the first quadrant. So you are only going to be looking at the first quadrant. Now, between 0 and pi over 2, okay, so 0 and pi over 2 are included. However, you can see m is neither 0 nor pi over 2. Cos cannot be 0 between 0 and pi over 2. So this is not possible, right? This is not possible between 0 and pi over 2. Okay, it's only true for pi over 2, but that's not what we want. M is a point that's between 0 and pi over 2. This is also a turning point, but that's not what we're looking for. Okay, so this is not going to give us M. Or you can do it like this. You can say from this you're getting x equals pi over 2, and that is clearly not m. That's not what we want. Okay, now from the second equation, since we know that the angle is between 0 and pi over 2, what we can do now is we can find the basic angle. Cos alpha equals under root 3 over 2. What's the basic angle that we get since we want an exact coordinate? Sine inverse of cos inverse of under root 3 over 2. What's that? Under root 3 over 2. Cos inverse of under root 3 over 2. That's pi over 6. Okay. So basic angle is pi over 6. Now, if the basic angle is pi over 6, cos is plus minus. This could be in any of the four quadrants because you have cos as plus minus. However, we know the angle is acute, so it has to be here in the first quadrant. This is what we're looking for. This is alpha. So what is going to be the x coordinate then? We say the x coordinate of the point M, that is pi over 6. And that is what we were looking for. The x coordinate of M turns out to be pi over 6. Okay. And that's it. That was March 2021, paper 3, variant 2, difficult questions from this paper. Okay, I hope that makes sense. We will end this here and we will meet again for our S1 class. We will be doing difficult questions from 3 papers today. November 2020, paper 5.1, paper 5.2, and 5.3 will start around 7:20 inshallah, but that's it for this session. I'll see you again in the next one. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.